So we have triangle ABC, and D is a point on side BC. So let's go ahead and, well, this looks huge. I don't think I need that big of a triangle for this particular question, but let's just finish it anyways. ABC, the point D somewhere. Let's mark it here. A line through D intersects AB at X and ray AC at Y, so I'm assuming it will be on the other side of AC. So I'll just go ahead and maybe something like that, I guess. Right, so this is the point D. So we have a point X here, the point Y, and maybe I don't even need I don't need this portion of the ray. All right, what else do we know? The circumcircle of triangle BX D. Okay, so that will be slightly ugly, maybe red. Okay, so we draw the circumcircle. That's not gonna be nice. Okay, so something like that. Well, I said it won't look nice, right? So therefore I have no excuse here. Maybe I can try to clean it up a little bit here. All right, looks good to me. Maybe make it slightly softer. So this is our point. Back to usual size. All right. So these two circles, circumcircle of BXD will intersect the circumcircle omega. Omega is this guy at the point Z here. Z, that point of intersection is Z, and at that stage, we draw the lines ZD and ZY. Okay, so let's go ahead and draw maybe gray. So I just draw ZD. I let it intersect the first circle omega at the point V, and similarly I draw ZY. Okay, so somewhere here it intersects at the point W, and then the claim is that the measurement, the length of AB and VW, these are both let me just draw VW by the way. Both are chords on the circle omega, on the circumcircle of triangle ABC. And to finish the problem, all I will do is to establish that the angles on the circles that meet those chords are congruent. So because AB is intercepted by this angle, all I need to finish the problem is to show that indeed angle VZW is equal to angle C. If I show that, because they are both of these angles are on the circle, then by law of sine, for instance, the extended law of sine, the chords AB and VW would be congruent. But that's a direct consequence of the fact that Z is a special point. Let me just pause the video right here if you don't want me to ruin the solution for you. Z is actually the Michel point. Z is clearly Michel point of the complete quadrilateral, Michel point of the complete quadrilateral AXDC with well, if you want, B and Y are the extensions of AX and CD, as well as AC and XD, right? So, but you guys, everybody sees the shape, right? So in fact, let me go ahead and so this is a complete quadrilateral, this and then that. Do you guys agree? So this is a standard shape of a complete quadrilateral. As a result, Z, because it's on the intersection of two of the circles, then necessarily it must be the Michel point. And as a result, the two missing circles of this construction should also go through that point, right? So that makes sense. So therefore, Z is equal to the intersection of ABC intersection, while those two are given BXD. But further, it should the circumcircle of YCD, as well as which one's missing? ABC, AXY all of these, so these two additionally also should pass through that point Z. But I don't even need this one. All I need is YCD. The way these 4 points YCD are, oops, maybe a different color again. Let's use black. So you have this nice circle here that goes through the point C here, D here, Z, and Y. So then it is clear that this angle indeed is congruent to this one, because this angle Z here, or VZW, angle VZW is equal to 180 degree of the opposite angle, this one, YCD, minus angle YCD, but 180 minus YCD is just ACB, angle ACB, which is just angle C. Aha, we have just proven that the angles intercepting the chords AB and VW, they are congruent. VW is intercepted by this angle, and AB here, the chord, is intercepted by angle C. Both of these angles are on the circle, and boom, we are done. That establishes that those two chords are indeed congruent.